If difference is around 0.02, little to no effect. Gradient, triangle method, use at least half of line. Whether values are the same, no. Difference too large for experimental inaccuracy, yes. Values are close within limits of experimental accuracy. Pendulum. Draw a diagram to show how to measure the diameter of a bob. Blocks arranged parallel either side of bob and touching bob. Rule correctly placed, touching the blocks and spanning the gap. How to judge that the 50 centimeters mark of a meter rule is vertically below the center of the bob. Use blocks protractor, set square, move ruler close to bob, lower bob. Precaution to measure height between bob and bench accurately. Take reading with eye line perpendicularly to rule, use set square to ensure rule vertical. Precaution to measure time for 20 oscillations. Repeats, start counting at naught. Precaution to obtain reliable results, improvements. Repeats, large number of oscillations and divide. Use additional values for independent variables. Why measure time taken for 12 swings rather than one swing? Reduces effect of human reaction error, reduce percentage uncertainty. Gives a more accurate value of t. T is too small, oscillations are too quick. Gives an average value of t. Why it may not be correct to state that both pendulums, hanging bob and rule, have the same length. Pivot at 1 centimeter mark. Center of mass of rule not 50 centimeters below pivot. Why value of acceleration of free fall is different from result. Student did not react quickly enough when stopping stopwatch. Difficulty in measuring accurately to center of bob. Measure length of pendulum, bottom of clamp to center of bob. Measurements. Why volume of air in tube not accurate. Finger increases volume, tube not pushed in far enough. Some water in test tube, air is compressed. Why volume of water in tube not accurate. Water remaining in tube. Water remaining in measuring cylinder. Tube overfilled, surface tension effect. Either one of the above error. Measuring cylinder not very sensitive. Subtraction produces large percentage uncertainty. Inaccuracy in measuring density of rock. Object not dried before measuring mass. Measuring cylinder not read at eye level, parallax error explained. Measuring cylinder not read at meniscus. Inaccuracy in measuring maximum volume of water in a cup by calculating dimensions of cup. Length on top of cup not liquid level. Length on top and bottom of cup not inside diameters. Difficult to measure height because of sloping side. Height not measured at eye level perpendicularly, parallax explained. How to measure circumference of pencil. Use at least 3 turns of string. Measure distance and divide by number of turns. Inaccuracy in measuring circumference of pencil. Stretching of string. Thickness of string. Thickness of mark. Gaps between turns. Winding of turns at an angle. Inaccuracy in measuring density of water. Measure mass in test tube and volume of air in test tube in a measuring cylinder. Balance not at 0. Test tube catches on side of measuring cylinder. Sand surface not flat top pan balance only to nearest gram. Measuring cylinder graduations too large. Inaccuracy in measuring volume of modeling clay. Measuring cylinder not sensitive. Some clay left on fingers. Cube not perfectly shaped, difficult to measure irregular dimensions. Repeat in several places for each dimension and take average. Air bubbles clinging to modeling clay, within the modeling clay. Volume of string. Difficult to judge the bottom of meniscus. Don't accept parallax or poor experimental practice, e.g. spills or splashes. Question says experiment has been carried out with care. How to obtain a more reliable value for the average circumference of a cup. Measurement of circumference halfway up, top and bottom. More than one revolution used for the measurement in at least one position and divide. Releasing stuff. How to ensure distance traveled and time taken by toy car are measured reliably. Making marks on track for start and finish. Repeats, find average time. Constant starting positions. Not pushing car. Time from same point on car. Use light gates, automatic timer for timing. Method for avoiding parallax when judging finishing point. Inaccuracy in timing when steel ball fall to sand. Human reaction time. Variables that affect diameter of hole created by steel ball. Size, mass, diameter of ball. Size of sand, grains, type of sand. Dampness, depth of sand. How to see more clearly where ball lands. Sand tray. Ink on ball. Balancing. Suitable mass which equals to mass of meter rule. 50 to 250 g. Difficulty, inaccuracy. Rule unlikely to exactly balance. Difficulty in achieving exact balance. Take average position, nearest to balance. Rule could slide on pivot. Mass could slide. Center of mass of rule not at 50.0 centimeters mark. Rule not uniform. Improve reliability of value of mass of meter rule calculated. Repeat readings. Why use a range of m values? Accuracy, reliability, check readings, spot anomaly. How to find the center of mass of meter rule. Balance rule on pivot with no load. Pivot balance point is at center of mass. Center of mass at 50.2 centimeters. How to prevent this from affecting results. Take readings from 50.2 centimeters or place pivot at 50.2 centimeters mark. How to make sure center of block is at the 40.0 centimeters mark on the rule. Measure half width of mass either side of 40 centimeters. Mark center line of mass and align with rule. How to find the position at which the meter rule is balanced. Move block back and forth to find the point of balance. Spring and load. Why cannot place a spirit level on the rule for checking whether the rule is horizontal? Would change force meter reading change mass on rule? How to check rule is horizontal. Check distance from bench is the same at 2 points. Suitable horizontal ref. Precaution to measure distance between bottom of spring and surface of bench. Always measure from same point on spring, top or bottom of ring. Wait for spring, wait to stop bouncing. Use of horizontal aid, ensure rule is vertical. Inaccuracy. Rule bends. Mass not exactly at 40.0 centimeters. Mass may slip. End of rule may slip. Hook not directly above 0 centimeters. Spring extension not uniform. Proportional limit exceeded. Mass irregular, center of mass not at center. How to extend experiment to investigate the suggestion that X and Y might be directly proportional to each other. Repeat with different sized loops different values of X and Y. 3 more sets of results and evaluate X, Y or plot a graph to check if a straight line through the origin. Whether results support suggestion that X is directly proportional to Y. X, Y is constant. X doubles when Y doubles. How to measure length of spring. Clamp rule. Rule close to spring. Ensure rule vertical. I perpendicular to reading. Use of set square fiducial aid. Y length of spring not measured to ring. Ring does not extend. Improvement to obtain more reliable values of F. Repeat all readings and take average. Temperature. Conditions that should be controlled. Drafts. Room temperature, humidity. Initial water temperature. Precaution, temperature of light bulb. Explanation of avoidance of parallax error. Waiting time between readings, wait for steady thermometer reading. Allow lamp to cool, warm up. Repeats and average. Precaution, temperature of water. Wait for thermometer reading to stop rising. Perpendicular viewing of scale. Stirring. Thermometer bulb in middle of water, not touching beaker. Which has greater cooling rate? Answer and justification with mention of temperature change. In same time. How to increase rate of calling. Higher starting temperature of water. Use of metal can instead of beaker, metal bench. Lower room temperature cold water bath. Use of a fan. Container with a greater surface area, larger beaker. It is difficult to read both thermometers every 30s. How to ensure readings are accurate. Place stop clock and thermometers so seen easily. Keep eyes at level to thermometer scales. Use an audible 30s alarm. Read thermometer alternately every 15s. Use of data logger. Ray tracing. Precaution. Large pin separation, greater accuracy with greater distance, easier to line up accurately. Ensure pins are vertical. View bases of pins. Drawing thin lines, use a sharp pencil. Use thin pins. Inaccuracy. Difficulty in aligning pins. Pins too thick. Thickness of mirror. Getting pins vertical, pins are bent. Drawing accurate, thin lines. Replacing block accurately on outline, outline larger than block. Effect of using less thick transparent block. Refractive index less reliable due to smaller block depth. Measuring smaller lengths gives greater percentage uncertainties. Lens. Precaution. Carry out experiment in dark room, no direct sun, light bright lamp. Lens and object same height, above bench. Lens, object and screen, mirror vertical perpendicular. Move screen, lens carefully back and forth slowly to obtain sharp image. Fix place rule on bench clamp rule. Mark center of lens on holder. Readings repeated, and average taken. Differences between illuminated object and focused image on screen, f less than object distance less than 2f. Inverted, bigger, brighter, dimmer. Colors seen round edge, edges blurred. Difficulty, inaccuracy. Difficulty in deciding exact position of lens for best image, image not quite clear. Difficulty in measuring to center of lens. Difficulty in measuring height of image. Hand get in way of image, fix grid to screen. Electricity, inaccuracy. Different heating effects on wires, wires may be at different temperatures. Different interpolation of readings between marks on meters, difficult to read the meter, or ammeter, voltmeter current, voltage, accurately. Difficult to measure length of wire to nearest to judge the position of the sliding contact. Cell may run down, power of cell may be less. Why cannot connect crocodile clips to very short resistance wire to obtain smaller P.D. Wire becomes too hot. Current exceeds full-scale deflection of meter becomes too large. How to reduce effect of resistance wire becoming very hot when the crocodile clip is connected to short lengths of the wire. Use smaller current P.D. Use wire with greater resistance. Open switch off circuit in between readings. Why use a variable resistor? Repeat with different currents OR to obtain a range of readings. How to investigate the relationship between P and R in more detail. Draw a graph. Different, more resistors, values of resistance, greater range of values for resistance. Use at least 5 sets of values for resistance. Observation that the temperature of the lamp filament changes. Brightness, intensity of lamp changes. Investigation, one factor that affects the time taken for metal balls to stop moving after being released on a curved track. How ball will move, back and forth like a pendulum. Release from a determined position, time until stops. Repeat with at least 2 more values of IV, CV, table, compare, plot, graph. Investigation, force needed to just slide a block across a surface affected by mass of block. Additional apparatus, force meter, masses. Diagram, block, workable means of pulling and measuring force. Measure force required to make block slide. Repeat for new value of mass. Precautions, same surface to slide on, repeat each measurement and take average, same angle of pulling force. Graph. Additional point. At least 5 set of datas taken, keep force horizontal, add mass of block to load, extra precaution. Investigation, strengths of different papers. Additional apparatus. How applied force is measured. Table per bar graph. Conclusion. CV, same width of paper, same thickness, weight, length of paper, all samples. Fixed in same way. Additional points 2 second CV, force applied smoothly, no jerking, ensure no tears before applying force, repeat for each type of sample, soft mat under weights, clamp stand to bench, add weight of lower block to value of load, suitable precaution. Investigation, how rubber band of different widths stretch when loaded. Measure length of band. Hang load, measure new length. Repeat with different thicknesses, widths. CV, use same length of band each time. Table. Conclusion. Plot graph. Additional point. Use same load, use at least 5 thicknesses, show how to measure extension e.g. L, use same type material of rubber band. Investigation, distance traveled by toy truck affected by mass. Place truck on ramp, and release. Measure distance from bottom of ramp. Repeat with different masses loaded on the same truck. Additional apparatus. Meter rule. CV2, height, angle of ramp, number of supporting blocks, release position, height above bench. Table. Investigation, effect of size of air gap on cooling rate. Water in copper can, time taken for temperature to drop. At least 3 large outer containers, separately. Indication that size of air gap is measured. Additional points 2, use of something to cover air gap, use of lid on copper can, same starting temperature, same room temperature, same volume of hot water, use of control with no outer container, inner container standing on an insulator, uniform air gap all round. Table. Conclusion. Investigation, whether type of container affects the time taken for water to be heated from room temperature to boiling point. Measure room starting temperature. Measure time to raise water temperature to boiling point. Repeat with the other 2 containers. CV2, same starting room temperature, same volume of water. Keep Bunsen burner flame constant, keep the distance from the flame to the bottom of the beaker constant. Table. Conclusion. Investigation, size of image affected by object distance. Diagram, lens, illuminated object, screen in suitable order, in line for flat surface. Instructions. Set measure object distance, move screen to get image, measure image height, repeat for different object distances. Limiting factor for range of object distances, image virtual too big for screen, image too dim too small to measure, must be greater than focal length. Graph. Precaution and consequence of not taking it. Dark room, bright light, image might not be distinct, lens and object at same height, image might not appear on screen, lens, object and screen perpendicular, image might be distorted, fixed rule, may move and give incorrect distances, mark position of lens on holder, cannot judge correct measurements, means of obtaining a sharp image might not be correctly focused, means of measuring height accurately, might be obscured. Investigation, determine focal length. Additional apparatus, screen and meter rule. Diagram, suitable arrangement of apparatus with U and versus labeled. Method, obtain clear focused image and measure U and V. Repeat for other values of U. Precaution for clear, focused image. Move screen slowly backwards and forwards, object and lens and screen perpendicular to bench vertical, object and lens at same height from bench, use of dark room bright light. Precaution for measurements. Clamp rule fixed to bench, mark center of lens on holder, avoidance of parallax explained. Additional point. Additional precaution, calculate f from given equation, at least 3 values obtained, calculate average. Investigation focal length affected by thickness of converging lens. Diagram showing object, lens, screen in correct order. U and V correctly labeled on diagram. Measure record calculate U and V and lens thickness T. Repeat with a different lens. Method of obtaining a sharp image by moving object, lens or screen. Use of blocks either side of lens and measure distance. Table. Investigation. Diagram if got. Measure. Precautions. Repeat for other 4 IV. CV. Table. Conclusion graph. Additional points. Other CV. Repeat each measurement and take average, at least 5 sets of data.